Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 3.48. The problem statement says, convert the temperatures in parts A and B and temperature intervals in parts C and D. Okay, so there is a difference when you're doing temperature conversions, that if you're working in temperature differences than if you're working in temperature absolute values, then the conversions go a little bit different. And the reason for that is the difference between scaling and translations. Okay, so the Fahrenheit scale and the Celsius scale are separated from each other not only from a scaling issue, but also they've been translated. Translated as in they don't begin and end at the same spot. So 0 on Fahrenheit is a different reference value than 0 on the Celsius scale. And that's why you have to translate the values. As you can see in, I've written down the function here for converting from Celsius into Fahrenheit. You can see here that you have to translate, after you convert, you have to translate at 32 degrees. And that's because if you just scaled it so that they were on the same scale, the 0 for Celsius would not change. But Fahrenheit doesn't have 0 at the same place that Celsius does. Celsius has its 0 at the freezing point of water, and Fahrenheit used a different reference value instead of zeroing on the freezing point of water. So you have to translate that value 32 degrees on the Fahrenheit scale in order for the Fahrenheit scale to match up with Celsius. And that's the same thing with Rankine, because Rankine and Fahrenheit are, as you can see here, Rankine and Fahrenheit are on the same scale, but they've been translated differently. So there's a translation value here that's different. Okay, so when you're doing temperature differences, the translation cancels out. Okay, so you don't include the translation when you're doing these scaling factors, but you have to do them when you're doing absolute values of temperatures. So if you're actually pointing to a temperature degree and it's on a certain scale and you're saying it is at 85 degrees, then if you want to change that into Celsius, you have to do the full translation value, because these translations won't cancel out. But if you do differences between Fahrenheit and Rankine, these translation values, or differences between Celsius and Fahrenheit, the translation values will cancel out. And so you don't include the translation value, you just include the scaling factor, which is 9/5. Okay. So, I mean, that's pretty much the whole problem. Like that, those are all the answers right there. That's why you see that each one of these values is different when you're talking about absolute value scale, or the magnitude of the measurement. But when you take temperature difference, you see that the temperature difference in Fahrenheit and Rankine is the same. And the temperature difference in Celsius and Kelvin, they're interchangeable. They're the same because they're on the same scale. But when you do the difference between Celsius and Rankine, or Fahrenheit and Rankine, you have to make sure you still scale it by 9/5. Okay? Well, that is it for problem number 3.48. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem solving videos. Thanks again, and I'll see you in the next video.